A set is a collection of elements where the order does not matter. For example, if we have a set consisting of several balls and two of them switch places, it is still the same set. Take, for instance, a simple quadratic equation. Let's say the solutions to the equation are x equals 1 and x equals 2. These two values form a set of solutions. Here, it doesn't matter whether we write them as 1, 2 or 2, 1, it's still the same set. The same applies to letters in a word. If we take all the unique letters from a word and collect them in a set, we see that the order does not matter, only which letters are included. But what happens when we have multiple sets? Here we can define some operations on them. We can take the union of two sets, which means we gather all the elements from both sets. We can also find their intersection, that is, the elements that both sets have in common. If two sets do not share any elements at all, we say they are disjoint. And here comes an important rule. If two sets are disjoint, we can determine the number of elements in their union simply by adding the sizes of the two sets. This is called the rule of sum. Let's take an example. Imagine you have 3 bowls of fruit and you want to determine how many different fruits you can choose from. If the fruits in each bowl are unique, you can just count how many fruits are in each bowl and add the numbers together. Now, when the order does matter, we work with tuples. A tuple is an ordered collection of elements, meaning that if we swap elements around, we get something entirely different. For example, in a coordinate system, if we have a coordinate x, y, the order matters. If we swap x and y, we get a completely different point. Similarly, if we take a word and rearrange the letters, we get a new word. When dealing with combinations, we can use the rule of product. Let's take a simple example. If you are choosing an outfit and you have 4 different hats, 2 different ties, and 3 different pairs of pants, you can determine the total number of outfit combinations by multiplying 4 times 2 times 3. This is called the rule of product. Let's look at a concrete example with numbers. If we want to form a 3-digit number where all the digits are even, we can use the multiplication rule. First, we identify which digits we are allowed to use and exclude those that do not meet the conditions. We can use the digits 0, 2, 4, 6, and 8, but we cannot have 0 as the first digit. This means that for the first digit, we have 4 choices, 2, 4, 6, or 8. And for the second digit, we have 5 choices, and for the third digit, we also have 5 choices. Therefore, we get 4 times 5 times 5 equals 100. This means there are 100 possible 3-digit numbers where all digits are even. Sometimes we need to combine both the sum rule and the multiplication rule. Let's take an example where we want to count the number of 3-digit numbers that contain exactly one specific digit, for example, digit 7. Here we can divide the problem into 3 independent cases. One where 7 is in the first position, one where 7 is in the second position, and one where 7 is in the third position. For each of these cases, we use the multiplication rule to count the possible numbers. Same as before, we first list all the possible digits and then leave only 7s in corresponding columns. Now, it's also time to remember that in all 3 cases, 7 cannot repeat. Thus, we remove the 7s from the remaining columns. 0 cannot stand in the first place, so it also has to go. We are left with a number of valid choices, which are multiplied in each group according to the rule of product. Finally, we sum the number of possibilities from the 3 cases, which gives us the total number of 3-digit numbers, where 7 appears exactly once. And this brings us to our final question. How many subsets does a set have? A subset is any possible selection of elements from a given set. We are not just counting subsets of a specific size. We need to count all subsets, including the empty set and the set itself. To find the answer, we can use a simple idea. Each element in a set can either be included in a subset or not included. We can represent this using 0 and 1. The same choice we have for each object in a set, to either include it in the subset or exclude it. If we apply this to all elements, we see that we can describe each subset using a unique sequence of zeros and ones. Now we come to the actual calculation. Since each element has two choices, included or not, and for the sake of having a unique identifier, our elements here are ordered, we are simply applying the rule of product. If we have n elements, the total number of subsets is 2 to the power of n. This means that the number of subsets grows exponentially as we add more elements. Thanks for watching. Reach out if you have any questions.